Okay, guys, let's start. In the last lectures, we learned about two-dimensional plot, and almost we learned all the things which is necessary for two-dimensional plots. For example, if you wanted to just plot one data sets of dependent variable across the independent variable, we have command plot. Then we have different colors in Matlab. We have different styles. We have markers. We can change the marker size. We can insert arrow text. We can write some things on the figures, or more, we can save the given figure in any file format, that is JPG, TIFF, EPS, so and so. Now, if we are dealing with data of two dimensionals, so we have two dependent variables which varies in a magnitude, or basically, if you have two data sets and we wanted to plot on one figure palette, we can have hold on as a command which basically holds one data on the others, and we can plot that across one independent variable. If those data sets are of different magnitudes, they basically have large variations in their own magnitude, then we have subplots, and in subplots we can arrange these subplots the way we want it, either in number of rows, number of columns, so and so forth. So, and we can change the axis length, axis form, we can change the line length, line width, so and so forth. We saw regarding the two-dimensional graphs. Now we will see something more to it, that's a graphics. So many times we really don't want to plot a line plots, but we wanted to do something different where we wanted to see how the data at our disposal looks like. Some data may not look good on a line plot, so we might go for a bar chart. So depends on the types of data or the data at our hands, we should choose which plot, basically a line plot, a bar plot, a counters, or a pie chart is best for visualization purpose. So many times we might encounter with plotting a bar chart. So bar charts is basically where we have the data, and the simple command is of bar, which basically gives you two-dimensional bar charts. So let's have an imaginary classroom with 10 students, and we know the percentage of marks obtained by these students, and we wanted to draw a bar chart of this data. So let me show you how do we do this. So I have a x which is started from 1 to 10. So I created an x, and then I have various students which obtain different marks or percentage of marks. So I say y is equal to percentage of marks, someone 67, someone 78, 90, 95, or 97, 67, and then 56. 1, 2, 3, 4, 5, 6, 7, 89, 75, and 45. So I have these students who obtain this data. I wanted to plot it. So simply I will say of y. That's all. Tells you a bar chart. Yeah, so this is the bar chart. The first student, from this data, we can say that the first student obtained 67%. So and so informations we can gathered from this data. We can even change the color of the bar. We can provide X label, Y label, titles, and so forth, same things. Uh, we can change the colors of bar. So for examples, let me try this, whether it works. I have a bar of Y, comma, let's say red. It goes. So the colors is changed. Okay. If we have stacked bar, so then we can have even a stacked bar. So I have the data 1, 2, 3, 4 of 3. So if I am dealing with the data which are grouped into some group 4, group 3, groups 5 groups, and each one has some elements, so we can plot even the bar chart for that one. So I have R is equal to, let's say, 2, 4, 5. So this has grouped in 3. Yes. 45, 67, 89. And then I have 45, 78, 90. Then I have, let's say I have this one. And then I wanted to plot it. So bar of R. See how it is looks like. So it is look like in a 3 different groups. Each one has 3 datas. I can even have a stacked bar. So here it has 3. I can stack this one after the other. So I have bar of R comma stacked. It worked. Yeah, it worked. So all these are stacked in 3 different bins. Correct. So this is general bar chart. So I have stack bar. You can specify the color in bar. Another thing is contour plotting. Basically, when we do optimizations, okay, so we optimize some functions with respect to some decision variables. Correct. In that case, we came across with plotting a counter plot. So we wanted to see what's the value of x and y at this particular surface. So what the value, if I have x value this, I have y value this, what will be the function value? So if that is the case came across, then we cannot have line plot or bar plot. We should have counter plots. Or in the general, if you are doing optimizations, we wanted to see where we are lying currently and where the optima is lying, in which function subspace optima is lying of this given function. So in that sense, we go with the counter plots. So for counter plots, we need to create the mesh. So mesh is created by a mesh grid functions. Okay. So for example, let us generate a counter map that shows counter lines for a given function g, which is a function of x and y. X and y is a decision variable, and g is my function. I wanted to optimize z. The mesh grid command is used to generate the matrix of the elements that gives range over x and y along with the specific section of increment in each case. For example, if I know that I wanted to optimize the functions where the decision variable x starts from -5 to +5, and another decision variables y which starts from -3 to +3. Someone of you might going to ask me questions why x and y are the decision variables, because g, I wanted to optimize the function g, which is a function of x and y. So I can manipulate the values of x and y and see the value of g, which is optimum in its own sense. So I should first create the mesh grid of x, y within given the range, and then I should evaluate g, which is x square plus y square in this given examples. So then I should have counter of x, y, z. Counter contour is a command for plotting the contour plot. So let's try this. So I have, let's say I created x comma y, and then I wanted to have mesh grid. My x first range from -5 to increment of 0.125, correct? -5 to 0.1 to 0.3, and then another function, another value of y is -3 to 0.123. So this is what the inputs given to mesh grid function. It has created its mesh grid x and y. We got x and y, and then we should have g. G is equal to x dot square plus y dot square. So I have x and y. So I find out g. So I got the g, and then I should have contour of x comma y comma g circle basically. So this is what the counter I got. So here you can find out x. This is y's value. This is x value. At any point of time, you can find out if my value of x is 2 and y value is 0. So I should get here -4 square. So value of my functions. So from this, I should understand where I'm exactly lying with my inputs values. And then if you wanted to see the text on this one, so there are properties, show text, text step, whatever may be that. So I can execute one for you. So I have c comma h. This is the output argument of counter plots. So I have x, y, g. I have my counter, and then I have set. I am setting what I am setting with h, which is the output for the counter plots. Set with h. Show text. So this is the property. There might be a lot of properties, but this is what I'm showing you. Show text on. If I have another property, level, where I wanted to see the levels. So text step get h level step into 2. Says undefined function on. Text step. Now we'll see that the function's value is entered on the functions after each every steps. If you have given it text step 3, it will show you after 3. Yeah, so 1, 2, third, 1, 2, third. This is what is the counter. You can even fill these colors in the counter. The last portions in the plotting is three-dimensional plot. One is a surface plot. We know that three-dimensional plot defines surface defined by the function of two-dimensional f x y. So if I have the functions like x e raised to power minus x2 plus y2, okay, or square, then create a script file for the following code. I need to do maze gridding. So my plot is starts from -2 to 2. Okay, I have x gridding, and then after x gridding, I evaluated these functions, and then I have surf. So the command basically is surf. So first I have x comma y maze grid, which is minus 1 2.122. So I have created my maze grid, and then I have directly write. I can evaluate my functions. G is equal to x dot x dot. So x dot into exponential of minus x squared minus y dot square. So this is what I have my G. Once I got the function evaluations, I can go for surf, like a contour. Surf x, y, g. You get this plot. Then you can see these plots, how it looks like.
Hello, sir.
You can
Hello.
see this valley. You can see whatever you want to see in your functions from this side or that side. So 3D. There's 3. So value of x, one thing's value of y, other things, and then the function value. Or if you don't want these functions to be solids, use plot 3. Plot 3. This is same thing but not solid. This comes by plot 3, this comes by 7. So these are these things available in Matlab for plottings. Now I hope that you people understood most of these plotting things. If you have any problems, please let me know. I'm going to stop here for 2 to 3 minutes. If you have any doubts or anything, please let me know.
Hello, sir.
Yes.
Sir, could you repeat what does that mesh grid function does?
Mesh grid basically, so let's say we have x value. Okay. So let's assume that we have functions which depends on two inputs. Okay.
Yes.
Two inputs. Then we have independent values of x and y.
Yes, sir.
Okay. So what mesh grid does, it tries to formulate a mesh of those two independent variable. Have you
Okay.
seen mesh?
Just like a graph it is creating, but in other
Sorry,
dimensions. Just
sorry.
like a graph, just like a graph it is creating, but in 3D.
Uh, it basically creates a mesh in the sense the values of x varies from its lower limit to higher limit, and values of your another variables also varies from lower limit to higher limit with a certain increments. Okay,
Yes, sir. Hmm.
so it's basically gives you matrix forms of your x and y in 3 dimension.
Sir, in the previous program, just the latest one, we use mesh grid in parentheses minus 2, 0.1 to 2. So this
Yeah.
value is assigned to both x and y.
Because we say that x also varies from -2 to +2, and y also varies from -2 to +2.
Okay. Yes, sir.
Okay,
Understood.
and look at the x. So basically we are giving, what we are giving only variations in our x and y. But if you look at the x, it basically gives you two-dimensional x.
Yes.
See this -2, -2, -2, 1.9, 1.8, 1.7 created a mesh structure
Yes,
up
sir.
to +2 with that increments.
Yes, sir. Got it.
Okay, any other questions?
Sir, also in the second line, g is equal to x dot. That dot it is utilized while raising to power something. So,
Yes.
but we've done it initially and it has not shown any error. Why is it so?
Sorry.
G is equal to x dot into exponent.
Yeah,
So we have put dot there and it has not shown any error.
I have put dot and it has not shown any error
Yes, sir.
because I wanted to multiply each and every element of x.
Okay, yes, array. Yes, sir. Got it.
Yeah. If it's a one-dimensional, I need not to put the dot. It's a two-dimensional. So I wanted to
Yes,
plot multiply exponential of all these things with each element of x.
yes, sir.
Is tomorrow's lecture is the last lecture before the medicine?
No, sir, we'll get 1 or 2 more lectures.
You will get 1 or 2 more lectures. Okay. Okay. The another topic I wanted to start is data handling. Uh, See, when we write big programs, we calculate some things. We wanted to save that data, and then we later on might wanted to plot, or there are some data that are available in some form Excel sheets. We wanted to read that data, utilize that data, do something on that data, and store again or save again in the Excel files or text files, so and so forth. So for this, MATLAB has a very excellent tools. So data import and export function provide access to the data files, other applications, web services, external device, You can read popular file formats such as Microsoft Excel, spreadsheets, text, images, audio, video, scientific data formats. There are n numbers of files you can read in MATLAB. Even the picture files, images file, you can read in MATLABs. But however, you need a little bit of expertise. At this point of time, I'm just going to introduce a very basic levels where we can save the data created in MATLAB. We can save in MATLAB. We can read the data from Excel sheets. We can save the data in Excel sheet. We can read the data from text files, so and so forth. The basic levels I'm going to explain here. However, audio, video, scientific data formats you can explore on your own. So, first things, when you write a programs and some data has been created and you wanted to save that, simple command is save, correct? So I am going to show you how the save works. So now let's me close all figures. Okay. Let's see. Again, I am going to utilize this. So mesh grid. So look at this workspace. I have the data at workspace X and Y. I wanted to save that. Simple command is save, correct? And then you write a file name. So I can write file name X Y data. Where it will go? Let me change first my folder path. So I change my folder path, and then I'm saying that X underscore Y underscore data is the name of my file where the data is available. And now I'm going to save X and Y. Look at this X space Y, enter. Now what we're going to do, we're going to see the data files in this PC C drive. Class of 21. And here, see, look at this. This is the data file. X underscore Y underscore data created on this ones. Okay, so this is the way we can save, or you can even save the data from the script files. So let's see. I'm just opening any script file. Let's have temp rod. I don't know how it is function file. Okay, so I opened this and I wanted to save these two outputs, the average temperature and total temperature. So I write save. This is temp data. I wanted to save average underscore temp variables and total underscore temp. I just execute this. Once I executed it, I go and look at my folder. So here, is there a problem? Save it and then execute it. So look at this, temp data file has been created. So in a script files, in a function files, if you wanted to save some of your data, you wanted to see how this data varies, you can use the command save, which basically saves the variables which you wanted. Now we can load the saved data. So for example, let's again we can go. So now there is nothing in my workspace and I wanted to load the data. So I wanted to see the data which I saved, temp data. So load is the command for loading, and then you write the file name, temp data, enter. So this data has been loaded here. So you can load the data, you can save the data. This is what exactly in a MATLAB we can do. Okay. There is another things to it. Excel files. So let's say we wanted to write this data available into the Excel file. Now look at this, my directory, there is no Excel files available. Now if I say XLS write is the command which can write the data, it will create an Excel file. So let's execute, try to do. So what I did, I wanted to write this A as some variables, some values, 23, 45, 67, 89. Okay, now I wanted to write it in an Excel file. So file name, or you can give the anything, is equal to text data.xls. So this is one command. It has created file name. Now I want xls write, write. This is the command xls write or xlx write. I have a file name. File name. I wanted to write A. Done. Enter. So let's go and look at our folder. So look at this text data. If you open it, you will see A. So A, 23, 45, 67, 89. You can specify where you wanted to save column numbers and your A, B, C, D, that's row numbers, all these things you can specify in XLS right. In a similar way, there is there is a command called XLS read for reading the data. So I have file name text data elx. If A is a time temperatures, I can write this sheet to Excel range and XLS write. There is simple way XLS read also. I can just write AA is equal to XLS read file name. Excuse me. So you see AA has been created which has these values. So to write in Excel file, there is XLS write. To read from the Excel file, there is XLS read command. You can read it from the text file also. The command is read table, then give the file name, data type, and then write table is for writing the table in your text file. We can read Excel file, we can read text file, we can save the data and load the data in Matlab. And there are n number of file formats which can be read and write in Matlab. So for example, Matlab formatted data, extension is mat, description saved Matlab workspace, import function is load, export function is save. Text, any including CSV and TXT. If your CSV file, the command is CSV read or CSV write. if you have delimited numbers, DML read or DML write, there is a text scan or there is a read table, a write table. For spreadsheet like XLS format, XLSM, we have XLS read or XLS write. And if we column oriented data in worksheet or range of the spreadsheets, if you know, you can give read table, a write table. Not only this, you can read all these files: DAC, CDF, FIX, SDF, or BMP, GIF, SDF, JPEG, JPG. All these files IM read or IM write. Audio clips, MP4, M4A, video clips, AVI, MJ2. All this can be read and write from the Matlab. You people can explore this. Okay, so today we learned about the graphics as well as how do we read and write the various files and file formats from the Matlab or into the Matlab. If you have any questions on this one, please let me know. Otherwise, I'm going to stop here for today. All these commands can be used in on the work command window as well as function files, script files. Okay, if you do not have any questions, I'm going to stop here. See you tomorrow.